Now let us discuss the topic of anomaly detection. Let's first look at what is considered an anomaly and what are really the outliers that are present in the data. And we will also see the types of outliers that can be potentially present. And we will see what are the various techniques that are available to us in finding out those outliers. The outliers are very important from the business perspective. And finally, we will look at some of the challenges in finding out the outliers from the data. So, first, let's define an outlier. It is a data object that is deviating significantly from the normal object. This is important. It is not representing a variation, but it is representing a significant deviation. And it is also necessary to understand that most of the data that we receive can have some noise, and outliers are not noise. It is something which is so significantly different that there is a reason for us to take note, and it is important for business to sometimes prevent. It is mostly related to the kind of fraud or some intrusion, etc. And the business is keen on identifying and responding. So if you look at noise, it is more of a random error, but the outliers are significantly different. So, and as it is, if sometimes the noise can also create problem with respect to finding out the true nature of the data. So it's a good idea if we can remove the noise before we start working on the outlier detection. And outliers are interesting for because they are both interesting for a statistical reason and understanding the events and understanding the threats or the business opportunities. And we should also look at a similar topic, that is the novelty detection, and how is it different from outlier. See, when we have this social media, there are many people who are tracking what is happening in the social media. It is possible that suddenly people are interested in a new topic, and that may look like a novelty to start with, and in fact it may come out as an outlier at the beginning. So some unusual event has happened and people started talking about it. But as it goes along, as it reaches the critical mass and more people start discussing about it, it will become more of a one of the mainline topics in the social media. So the novelty detection helps in some agencies or some organizations finding out something that is about to take off, either in the society or in profession or in the business, etc. And some applications that you can see, these are very important applications for those businesses. So, for example, the credit cards, there may be millions or possibly billions of transactions that keep happening every day, but it is the few fraudulent transactions which can make a significant impact on both the credibility of the credit card organization and also cause a lot of issues or possibly even litigation with the customer. So they're interested in observing and take any possible steps to prevent the fraud. And similarly, in the other industries, either in telecom or the other areas, or let's say in a network intrusion, so or something related to a malware started spreading, so we want to identify it and take action quickly. So if we look at why we should study the anomaly detection, this is an interesting story. As you can see, the one of the big concerns that people have with respect to the environmental challenges is the ozone layer depletion. And interestingly, in way back in 1970 itself, some British scientists have noticed that the ozone layers, in fact, the ozone levels at Antarctica are dropping significantly. But then they know that there is already an American satellite Nimbus 7 which is monitoring the ozone layers and is recording the ozone levels, and it has not reported anything significant. So they, in fact, for a decade, they did not publish their work, thinking that there may be some error in their observation because the satellite is observing far more closely. But it is only when they saw no way they could be wrong, they published it, and then the satellite agency had checked up why they could not detect it, and they realized that they had a computer software which was not handling anomaly. So when it saw a data which is significantly different from the normal observation, it was simply ignoring it. So why is it a problem to detect anomaly? The point is that the outliers are rare. I mean, if they're common, then possibly things would have been very different and people would have developed a clear business logic. But then it is likely that out of the billion credit card transactions, maybe a handful of them are fraudulent. But we need a mechanism to identify that. And it is also, there is no set pattern to determine it. There may be several parameters where we need to observe before we can determine that it is a outlier. So it is somewhat like a clustering problem which is unsupervised, though there are attempts by some people to use supervised techniques to find outliers, but there is a limited possibilities there. So it is somewhat like you are searching for a needle in a haystack because the regular data is so large and outliers are few. So in fact, this is the observation, the working assumption with which the outliers need to be studied, that there are far more normal data compared to outlier. So if we want to classify or find out the types of the outliers, we may categorize them using one approach, which is the global, contextual, and collective. The global outlier is somewhat a anomaly point which can be which is noticeable from the entire global data. And so we can find some measurement of deviation whereby we can recognize it. And the other possibility is the contextual or conditional outlier. So this is, for example, we noticed that in some city in India, there was a temperature reading of minus 10 degrees, let's say in the central India. So it is not unusual in the world for some locations to have a temperature of minus 10 degrees, and there will be many parts of the world where the temperature is possible. But it is unusual because it happened in a city where the usual range is much different. So in a global context, you cannot say minus 10 degrees temperature is an outlier. But in the context of the location and possibly the time or month of the year, etc., you can say that it's an outlier. So you need to first find out the contextual attributes, in this case, let's say time and location, and then the behavioral attribute, which is what we are finding it to be an outlier. So this is the temperature. So this one, we may look at it as we may generalize it as a local outlier problem, where we combine all the attributes and then we try to solve the problem, saying that a combination itself is representing a outlier problem. But we need to first identify what is a meaningful context. So what are all the attributes that you should study before you identify that, because they may be 10 variables, and out of them one is impacted, that's a behavioral attribute, and the 9 are contextual attributes. First we need to identify which is contextual and other is which is behavior, and then we also need to be able to model the relationship. So the other type is a collective outlier. So here it's not just one data object, but it's a set of data objects that deviate significantly from the whole data. And in this case, so it is not that we are looking at one which is a very isolated. So an example can be a denial of service attack that is started because of a malware which has spread, and then it could capture some 100 machines, and then all the 100 machines they were vulnerable, and then some hacker got control of those machines, and then all of them participating in the denial of service packages. So now you need to find out, because in this case, as you know, if there is a threat, this type of threat, it is not necessary that just one machine in the world will be affected. It is likely that there will be several machines that will be affected, and so you possibly need to look at it as a collective outlier. And here you need again different mechanism. So first you need to have the background knowledge and the relationship among the data objects, and then the similarity or distance measures. So, and you need to look at the behavior of both individuals and also groups. And as a matter of fact, an outlier can be of multiple types. So now let's look at some of the techniques that we have for outlier detection. First, we'll look at a supervised method. Though it may not apply in many contexts, let's look at this is one technique which we can use when we have a clear-cut labels with respect to what is appropriate or what is normal and what is abnormal. In that case, we can divide the data into clear-cut two classes. One is normal data and other is abnormal data. And we can possibly use the classification techniques and determine which are all the points which are representing the abnormal data, and we can simply put them as outliers. So first we need to model this to solve this classifier problem, and then the thing is that there needs to be a training data for that. So the classifier has to learn, and then you need to look at, you need to apply the classifier on the remaining data, test data, and get the result. So the problem is that here it is a clearly imbalanced classes, as we had discussed. The outliers are far fewer than the normal data points. So in that sense, we have classes which are highly asymmetric. So in this case, the point is it is very difficult to create a model that works accurately. And sometimes we may insist that it is important that to catch as many outliers as possible, rather than worrying about are we mislabeling some normal objects as outlier. So in that case, we may be able to solve this problem, because we may create a model which catches all the abnormal or the outlier points, and there is no problem if it catches something little more than that. And the general technique is unsupervised methods. So here what we have to do is that we need to think in terms of what are all the points which are the data objects which are normal, and we use the unsupervised learning techniques to clustering them either into one or multiple clusters, and look at the data objects which do not seem to fit in there. So the challenge here is that the first challenge is it has a challenge with respect to collective outlier. So if you have a collective outlier, we are saying that there are multiple data objects which are all compromised or which are all representing abnormal behavior. So in such case, that will be represented as a cluster in this case. So it will be difficult to find out that. Because what happens, as you can see in an example, if there is the virus or some intrusion is happening, so it is quite likely that we will end up with creating a large number of false positive, and also potentially we will miss the real ones, because we need to look at we do not know the behavior of the virus. So the point is that the machines which are in normal state, they will be operating in diverse ways, but we do not have a model of how the infected machine will behave, because we are clearly looking at a new virus. So in this case, the unsupervised method will be challenged. So many a times the clustering methods, what they do is that they first find the clusters and then outliers. And here the challenges are with respect to distinguishing noise and outliers. And also the point is that first they need to completely execute a clustering algorithm. So that makes it costly to find the outliers. So there are the newer methods that people are working on try to tackle the outliers directly without creating a cluster analysis for the entire universe of data. And sometimes we go with semi-supervised methods. So here what happens is that the labels are going to be small, and only outliers we give the labels, and for the normal data we don't bother. Or what we can do is that we give labeling only for the normal objects, and we look at what are all the objects which are not getting any label. So in this case, what we have to do is that we'll have to use the labeled examples and then find out the proximate which are close by and the unlabeled objects, and then we will have to train a model so to identify the objects which are close to labeled objects and consider them as the normal objects, and then where you are unable to reach through some distance measured to the objects which are through this technique for which the labeling has already been done, then you may consider that as a outlier. So essentially you first need a labeled example. So essentially you first need a equivalent to a training data. So the thing is that if there is a labeled outliers, so the challenge is that if the outliers themselves are of distinct types, they may not be able to cover all the outliers. So in that case, we may have to still take the help of unsupervised methods. So to find out the contextual outliers, so what we can do is that the first technique is that we transform the contextual outlier problem into the conventional outlier problem. So first we will be identifying the context using the contextual attributes, and then calculate the outlier score using the detection method. And then we are going to compare the other data objects with similar contextual attributes, and then there we can apply a conventional outlier detection method. So that is, we have already separated out the data objects based on the contextual attributes. So you can see here an example of what you can possibly do. The other technique for mining the contextual outliers is with respect to modeling the normal behavior with respect to a context. So if we can find out, for example, if this is the age, this is likely to be the purchasing habits, then having modeled the normal behavior, then we can find out wherever there is a data object which is violating this normal behavior. So here essentially you require a training data, so that will help you predict the expected behavior. And if the contextual outlier is the one where the behavioral attributes differ significantly from those which are predicted by the model which has been created by a training data set. So in this case, there are numerous prediction and classification techniques that can be used. And finally, looking at the third type of outlier, which is a collective outlier. So here we are talking about the ones where all their behavior is not normal with respect to the others. So, and again, when we are looking at the structure of what constitutes that group, we can look at it from several perspectives depending on the type of data we are looking at. Sometimes we may be looking at a time series data, and we see that the behavior seems abnormal. Let's say in 2007 between May 5th and May 25th. So essentially in a temporal data where there is a time series or the sequence. So what we are seeing is that there is a segment of the time when it behaved differently. So that may give an explanation with respect to why we are finding an outlier there. And it's also possible that we can use similarly the spatial parameters. So we can say that within this specific geography, we are observing the behavior which is an outlier. And that again can be something important and useful. And the same thing can be generalized, and we can find it within either a graph or a network data. We'll be able to find a subgraph that is representing the outliers. So here, if we want to solve the problem, again, we may try first to reduce it to a conventional outlier detection. In that case, first we need to identify the structural units. So then we need to start extracting the features, and then we will be matching the data object with respect to the expected features based on what we had created as the structure units. So it is again something like we are creating within a time. We can say that 1 week is a time unit, and then for each week we are making a comparison, and then we are finding the week where there is a problem. So as you can see here, we are clearly scoping out first because we are creating the structure units, and so we are making some sort of assumption with respect to the structure unit. So in a geography, we can possibly say that a village is representing a structure unit or a city is representing a structure unit. So in this case, we are making some assumption about the structure unit, and then we are trying to solve the collective outlier problem. So other approach is that we do not make any such assumptions, and we try to determine something as an outlier first by studying general characteristics and then trying to create a subgraph based on their behavior. So here what we may see is that a social network where some of the connections, they seem to be behaving abnormally compared to the other connections. And we may create a Markov model and then identify any subsequences which are significantly deviating from the model. So essentially this is a significantly an application dependent problem. For example, whether we are finding out an intrusion in a network, or we are finding out some transactions in the stock market which are violation of the law. So in such situations, the city context determines the heuristics that need to be used. So in that sense, the outlier problem has to be solved in appropriate way. And here the computational cost is likely to be high because we are working with multiple parameters. So finally, looking at some of the challenges in outlier detection. The first challenge is that we need to find a model that represents the normal object and an outlier. And it may be that we will have numerous models which represent the normal behavior. So in that sense, it is not one model which is going to differentiate. So we need to find out all possible normal behavior models. And added to that, it is not easy to find out the borderline between the normal and the outlier. And the application knowledge is very important, as we have discussed what is a credit card fraud and what is the malware attack. In both these contexts, the knowledge that is required is very different. As you can see in an example, if you're looking at a clinical data, a small deviation can make an outlier. But when we are looking at a marketing analysis, it's possible that significant fluctuations are acceptable. And an outlier detection works only if we can handle the noise well. So if we cannot differentiate the noise and outlier, so we are going to report many false positives. And finally, the outlier detection requires understandability. So there should be a basis on which the event that has been observed by the data analyst or the business analyst can determine that it is indeed an outlier. So if they do not find any logic or a reasonable basis, then they will not have a confidence with respect to the detection process.